Hi everyone, today we are going to discuss about a topic called Gauss law. Okay, so in the electrostatics, so presently we have already discussed about Coulomb's law, how to find out the force between the two charged particles, and electric field produced by the charges, and electric field for distributed charges, and potential energy and dipoles. Now, while finding electric field for some of the distributed charges like rod, sphere, so we have gone through a method called as a integration method by taking a small element, then for that what is the field produced is assumed as a dE, and we integrate over the entire limits, so we got the total electric field for the entire charge distribution. But now we are going with one more technique, one more law proposed by Gauss. So it is very easy to calculate the electric field due to that type of distributed charges also. It's like a shortcut method. It will be useful for finding any field, but mostly we will use for finding the electric field for a symmetrical charge distributions. Symmetry. If there is a symmetry, then we can use this Gauss law to find out the electric field. Right? Now, in this class, we are going to discuss about 3 topics. The topic name is Gauss law. Under this we are going to discuss about electric flux. So what is Gauss law and what are the applications of Gauss law? Applications of Gauss law. So 3 topics we are going to discuss. It is a very easy topic actually. So a simple topic, so that we can get problems very easily. The first one is electric flux, the second one is Gauss law, and third one is what are the applications of the Gauss law. Okay, so these are the topics we are going to cover in this class. Now, coming to the discussion of Gauss law, before that we should know what is electric flux. Okay, the first topic we are going to discuss today is electric flux. So electric flux is represented with a symbol called phi. Sir, what is actually electric flux? Take a plain surface, take a sheet of paper. Now, if I have some electric field lines, you know that from the positive charge, field lines will start. From the negative charge, field lines end towards the negative charge. Now I have taken some field lines are passing like this. So some field lines are passing like this. Now, sir, what is flux? Flux means the number of lines crossing this plane normally. For example, if I take 100 lines are coming through this area, if 20 lines only going, the remaining 80 are going in this way. Now the 20 is called as flux. So flux will tell you how many total number of electric field lines crossing a plane normally, crossing an area normally. That number will give you, that number is called as a flux, just a number. Okay na? So here that according to the definition, electric flux is nothing but the total number of electric field lines, electric field lines crossing an area normally, crossing an area normally. So the number will give you that flux. If number of lines crossing more, we can say through this area flux is more, flux is more. So like now I am going to tell you, this flux depends on what parameters? Electric flux depends on what parameters? Now I will take a plane, I will take a sheet like this. Let me take a sheet. Now I kept like this. I kept the sheet like this. Okay. So as a two-dimensional, I am drawing like this. Now, if there are some lines are coming like this, so these are called as electric field lines. These lines are called as electric field lines. Now see, here some lines are going, but how many of them are crossing this plane? Only this number. So you can say that out of total number of field lines, some of the lines are passing. This total number is called as flux. The lines passing is called as flux. Now sir, this flux depends on what? Depends on what parameters? Sir, if I increase the field strength, means now see the lines are very distant. Now if I say the lines are very crowdy, means if I increase the field strength, or intensity, we can say capital E. If I increase the intensity, more number of lines will pass us now. So more number of field lines you may see. So the flux also increases. So flux depends on the first parameter, electric field intensity. Now sir, if I take one more plane with less area, now through this more number of lines are passing or less number of lines are passing now. So here through this area is lesser. If A1 is taken A2, and you know that A1 is less than A2, now through this area, now the number of lines passing is less. Means the flux depends on the second parameter, area of cross section. Area of cross section. So flux depends on the field strength. Second one, flux depends on area of cross section. Now I may say that the sheet may not be like this. Here the sheet is like this, so that more number of lines are passing. Now if the sheet is like tilted, if the plane is oriented at some angle, then see here 20 lines are going. When I tilt it like this, some of the lines are going other the part of the plane, so that the number of lines may decrease, the flux may decrease. So that is called as orientation of so orientation of plane or area, you can say. So orientation is nothing but angle. For example, if I keep the plane at some angle to the electric field, for example, this is a plane, I am just the area vector, this is called as n cap, which is called as normal area vector, and the field is like this. This is the field. So field direction is E bar like this. So it means that this area vector is making an angle theta with electric field. So that is why we can say that, so area vector is like this. So now what flux is going through the area? See this E, I am dividing into two components. One is along this one is E cos theta, perpendicular is E sin theta. It means that this is in the plane, this field is in the plane. It means this field is not coming perpendicular to the plane. So which component is coming perpendicularly normally? Here E cos theta. So that is why you can say the flux depends on cos theta. So that is what orientation is nothing but cos theta. So we can say that the total flux depends on electric field strength, area and cos theta, so that we can simply write jo flux is directly proportional to electric field and area and cos theta. If you can say directly proportional k, which k is equal to 1, then you can say flux formula is E A cos theta. And in first year we may learn this as E A cos theta is nothing but A B cos theta. It is a dot product of two vectors. So you can write this one as flux is equal to E bar dot A bar, where E bar is the electric field, A bar is the aerial vector. Means for the plane normal will be taken as aerial vector. So and theta is the angle between electric field and normal, right? So this is the flux formula, E bar dot A bar or flux is equal to E A cos theta. Sir, then what are the units of flux? SI unit of flux. As you know that E and A, if you know E and A units, then flux units are same. So you know that U units are Newton per Coulomb into area units are meter square. So Newton per Coulomb meter square, or in electrostatics we know that electric field is equal to V by D, potential by distance. So or we can say potential is volt per distance is meter and area is meter square. Hence we can say 1 meter cancels. So volt meter also the unit of flux. So simply flux is nothing but how many number of lines are passing through the surface normally. So what is the formula for flux? E A cos theta in the vector form, dot product of electric field and aerial vector. Sir, will the all areas are like plane? No, some areas may be curved. Then what to do with those type of things? Let me take a curved surface where this is a small element. This is a small element where its area is called as dA bar. dA bar. D means a small element. For the entire object, we are just taking a small element. Now, if there is a field like this is the field E bar, and what is the angle between them? Theta. Now, you just find out flux through the small element. So, flux through element small element is given as d phi. So d means a small. D phi is equal to, you know that the formula of flux is E bar dot A bar. So electric field is E bar dot product with area is what? dA. So dA bar. So as we got the small flux linked with, now if you want for entire object, then we need to integrate. So then total flux is nothing but, I want total flux which can be obtained by doing integration of d phi, which is nothing but integration of E bar dot dA bar. So this is the formula to find out electric field for some distributions where small element is taken. So in some textbooks they may use the area symbol as S also. So here area they can write E bar dot S also. Sir, why? Because surface area. So you can write the flux formula as E bar dot dA bar or E bar dot ds bar also. Okay na? So now how many formulas we got? We got the flux formula E bar dot A bar or EA cos theta, and if it is a continuous bodies, integration of E bar dot dA bar. Okay. Now based on the angle we may say that whether the flux enters completely or no. Let me take, there is a plane like this, there is a plane kept like this. Now field lines are going like this. This is electric field. Now as this is area, when area is like this, what is the area vector direction? Area vector direction will be like this. This is area vector. Now what is the angle between the electric field and area? Electric field E bar is like this. So angle between them is 90. Now can I say like this? So the field is passing in the plane, not passing perpendicular to the plane. There is no line going perpendicularly. All the lines are going along the plane. So here angle is 90. So we can say that flux is equal to simply EA cos 90 degrees. Even the electric field value there, A value there, but cos 90 value 0. So that is why flux is equal to EA into 0. So flux linked is 0. So there is no flux passing through the plane. Why? Because electric field is in the plane, angle between the electric field and area vector is 90 degrees. Now let me give you a small thing where how to find out the flux. I have taken a cylinder like this. So this cylinder has this area A and this also A, and you know this is a curved surface where you can take this a small area as like this. This is dA3, you can take, no problem. Now if the electric field is horizontal, now I would like to find out flux passing through all surfaces, See, simply you can say that here flux is entering, the number of lines will enter and they pass through the body and they leave, so that there is a flux linked with this surface, but there is no flux linked like this simply. So I can say that this is 1, 2. Now flux linked with the first surface is equal to, you know the formula, electric field dot product with A. Now see, at the first surface electric field is like this, and what is area vector direction? Area vector always taken for a closed body, area vector is always outward, means for for this area vector is like this. This is A bar outward because it is a closed body. For this area vector is outward like this. Now you can say that for this surface electric field is like this, A is like this, angle between them is 180. So you can say that EA cos 180 degrees. As cos 180 degrees is -1, can you say like this, this is minus EA. So I can say that flux is negative. Flux is negative. It means if it enters, you can take flux is negative. Now what is the flux through this surface? Again the formula is E bar dot A bar. Now here electric field is horizontal, you know already, this is electric field, and area vector also in the same direction, so angle between them is 0. So you can say that EA cos 0 degrees, cos 0 is 1, so that flux will be EA. See, the flux is positive, this is positive. So flux entering we treat as a negative, flux leave taken as positive. Now what is the flux through this curved surface? See, every curved surface, the elements are, area vectors are perpendicular to the field because the field is horizontal. And if you take any curve, any element on the curved surface, its direction will be 90 degrees with the field. That is why simply E bar dot A bar, which is equal to EA cos 90 degrees. As cos 90 degrees is 0, so that flux through this one is 0. Okay. So this is how to find out the flux. So electric flux passing through a surface. Okay. Now we will discuss problems. So if you know dot product and if you know angle between the vectors E bar and A bar, then flux calculation is easy. Okay. Here the first example is, there is a square frame of side, a square frame of side 10 centimeters with its normal making an angle 60 degrees with electric field, 60 degrees with electric field of 20 volt per meter. Then find flux. Then find flux passing through that square frame. What they said? They have taken a square frame and with its normal, positive normal you can say, is making an angle 60 degrees. So I am taking a square frame like this, where its normal vector is like this. This is area vector. It is impossible to draw the, I will draw like this, a square frame like this. Its area vector, this is called as a normal vector or area vector, which is making 60 degrees with field, 60 degrees. Now what is the flux? See, as we know that flux formula is E bar dot A bar, which is equal to EA cos theta. Now angle between the electric field and area vector is 60 degrees given. So that simply flux value 20, area is side square, you can say it is 10 centimeters. You know that side into side is the area, so it will be 100 centimeters square because area is 10 centimeter into 10 centimeters. It will be 100 centimeter square, which is, you can write as 100 into 10 power minus 4 meter square in SI units. So 100 into 10 power minus 4. Here theta is 60. So cos 60 degrees is 1 by 2. So that 1 by 2 cancel with 20 as 10. So the answer will be 0.1. So flux is 0.1. You know the units, you can simply take voltmeter. Okay. So this is when simple question is given with area vector and electric field angle. Okay na? Right. We'll see one more question. So this is the flux based on simple formula. Okay. Then for example, a charge is placed at center. A charge capital Q is placed at center of sphere of radius some a. Then find flux through the entire surface. So here they have taken a spherical surface whose radius is a, and at the center they kept a charge q. You can say that charge q is positive, and you may say that from this charge electric field lines will start. So you can say that field lines will start like this, they go like this. So you can say some lines are starting and they are crossing the plane, that surface, spherical surface. So definitely some flux is linked with the surface. Now they are asking what is the flux, and I am just taking a small element. This is element and its area vector is like this. This is d a bar direction, and we know that here electric field also in the same direction, because electric field also E bar is also in the same direction. This is E bar direction. Okay, and we know what is electric field for a electric field due to the point charge, 1 by 4 pi epsilon naught charge by the distance from here to here is the radius, so that a square. Okay na? So this is electric field. Now they are asking flux, and you know that electric field and area vector are both in the same direction. So theta is 0 degrees. So theta is 0 degrees. Now you can say I am taking for a small element. Now what is the flux for a small element? D flux is equal to, you know that electric field into dA bar, so that you can say E into dA into cos theta. As cos theta is 0, it is 1, and E into dA you can place. Now I want total flux, so I need to integrate this d phi, so which is nothing but integration of d phi. So E value I am just writing as 1 by 4 pi epsilon naught q by a square into dA I am just taking as dA. This entire thing is constant, take it out, it is not participating in the integration. Now it becomes 1 by 4 pi epsilon naught q by a square. Now we need to integrate only dA. So integration of dA will be called as area, because integration of dx will be x. Like the same way integration of dA will be a. What is area of the sphere? Area of the sphere is 4 pi r square. So then you can say that, so flux is equal to q by 4 pi epsilon naught a square into area of this sphere is 4 pi a square. Now 4 pi cancels, a square cancels. Now flux linked with the surface is equal to charge by epsilon naught. Actually this is generally called as a Gauss law also, I will explain you later. So this is how to find the flux through the surface when charge q is placed inside the sphere of radius a. Okay. Now let me see one more question. For example, the electric field in a region is given by E bar is equal to 0.6 I cap plus 0.2 J cap, 0.6 I cap plus 0.2 J cap Newton per Coulomb. Then find flux through a surface of area 0.2 meter square parallel to YZ plane. See, they have given electric field. See, this is I cap, J cap means electric field is in the X and Y plane. X and Y plane. This is X axis, this is Y axis. The electric field lines are like this, XY plane. And now they are asking flux through an area which is this plane is parallel to YZ plane. Let me take this as X, Y. Now the plane is like this because they said in the YZ plane this is Z. So this is Y, this is Z, means I can say the plane is like this. The plane is in this plane. The surface is in this plane. Automatically for this YZ plane the area vector will be X axis. This is area vector direction. So as the plane is in the YZ plane, its vector will be A cap. Direction of the vector will be simply X axis, so that I can take I cap. So that is why I am now here I can able to take A bar as area vector as what is the area? 0.2, which is in the direction of X axis, so that I cap meter square. Understand? The surface is in the YZ plane and its area vector will be, you know that for the YZ plane X axis is the perpendicular. You know that X, Y, Z are perpendicular. So that is why area vector is in the X axis. Now it is easy to find out the flux because you have E bar, you have A bar. So flux is equal to, you know that when they have given in a vector form, electric field dot product with area. So flux is equal to, what is electric field? 0.6 I cap plus 0.2 J cap dot product with area is 0.2 I cap. You know that. So units are, you can write aside, no problem. You know that dot product can be in between the same components I, J, K. Now here I we have, here I we have. So multiply. So 0.6 into 0.2 is 0.12 and here J with I is 0, J bar dot I bar is 0. So that is why flux will be, okay na. So flux will be 0.12 voltmeter or Newton per Coulomb meter, okay na. So this is how to find the flux through a given surface when they have not given directly the area vector. They have given the plane and we need to find out the area vector for that, and electric field is given, okay. So we will see one more. For example, the electric field in the region, the electric field in a region is given by E bar is equal to E naught, just it is a value, by L into X I cap. What does it mean? The electric field vector I cap means it is along x axis, the electric field direction is x axis, and it is E naught by L. You can take E naught as some constant values, and x. So electric field depends on x, means as the x axis x value increasing, the electric field also increasing. If you keep x value 0, means at origin x equal to 0 is origin, means if you keep x value 0, electric field is 0. If you keep x value 1, electric field will be E naught by L. If you keep 2, likewise. So in field is a variable function. Now they are asking find flux through a cube. Find the flux through a cube as given in the diagram. How the cube is. So that cube is in the XYZ space, you can say. This is x axis, this is y, and this is z. So I can just construct a cube by taking this is x equal to 0, and cube side is I am taking as some a, okay na? So x equal to a. Now I can construct a cube like this. Okay na? So x coordinates are